Welcome to qnawire.
Here in this problem, the mass of automobile is given as 1500 kg. That means MA is equals to 1500 kg, and the mass of automobile brake is given as 6 kg. And the initial velocity of car is 25 meter per second when the brakes are applied, and the temperature of a brake initially it is 20 degrees Celsius, and we have to assume that the mechanical energy is converted into internal energy of the car when it stops. So we have to find that how many times brake can be applied so that brake is not melted. So we'll use the first law of thermodynamics, and from that we can write, first of all, let us assume that let n represents the number of time we can apply brake. So now we can apply the first law of thermodynamics. So n times E will be equals to mc delta T. So A is the energy of the vehicle, so it's n times energy will be equals to half mv square because it's a kinetic energy. So 1 divided by 2. Mass of automobile is 1500 kg. So 1500 kg times the velocity square. Velocity is given as 25 meters per second. Whole square will be equals to, here we have to take the mass of brake. So the mass of brake is 6 kg, and the specific C is the specific heat of aluminium, and the specific heat of aluminium is 900 joule per kg degree Celsius. Now delta T will be equals to the melting point of aluminium minus the temperature of brake. So it will be equals to, the melting point of aluminium is 660 degrees Celsius minus 20 degrees Celsius. So we can write 640 degrees Celsius. From here we get the value of N as 7.37. So finally we can conclude that we can apply 7 times. We can apply brake 7 times before the brake melts. So the final answer is, because n cannot be in decimal, so n will be equals to 7. So this was the answer for the A part. Now next we will be solving the B part of the question, and in the B part we have to tell the real scenario of warming of brakes. Now as the car stops, it transforms part of its kinetic energy into internal energy, and this internal energy increases the temperature of the brake. But as soon as the brakes rises, the temperature of the brake rises above the air temperature, they transfer the energy by heat into the air. So finally the temperature of the brake cools. So this is a scenario, this is a real scenario what happens when the brakes are applied. So I hope you got the problem. Thank you.